So for the function, find the domain. So let's find the domain first. So for domain, we have to look at this right here. So we have 3 and 5, and x has to be less than 5. So it has to be open parenthesis, negative infinity, and greater than or equal to 5, so including 5 and here. So it will be negative infinity to 3, union 5 to, including 5, bracket to infinity. So this is domain. So in order to find any intercepts, for y-intercept, we plug 0 for x. So when is x 0? X is 0 for this case. X is less than 3. So we plug 0 here. Then we'll get 0 squared, which is 0. So we get 0, 0 as an intercept. In order to find x-intercept, we have to solve this entire equation equals 0. So ideally, we have to look at both of them. When is each of them equal to 0? This gives us x equals 0, which we already used here. But for this one, we cannot plug 0 here because this square root we can only use when x is greater than or equal to 5. So this one does not give us any intercept. So just same thing as origin, we get 0, 0 as intercept. So this graph will pass 0, 0. So now let's try to graph this function. So here, when we graph piecewise function, it is useful to draw one piece at a time. So let's draw this first. So here's 1, 2, 3, 4, 5. Here's 3, 5. So we're going to draw less than 5 first. Sorry, less than 3. So the x squared, the quadratic, this is parabola, it has shape of something like this. And of course, we can pick some points, right? When it's 1 is 1. When it's 2 is 4. 1, 2, 3, 4. When it's 3 is 9. So maybe it's all the way here. And same for negative values, right? Negative 1 give us positive 1. Negative 2 give us positive 4. Negative 3 give us positive 9. So it has parabola shape, like this. Curve shape, something like this. But again, this only works when it's x is less than 3. So at 3, maybe somewhere here, all this portion, we have to exclude it. So let's just erase it. So we can think as we erase this portion. And at 3, it should have open circle. Again, this arrow means it goes off this forever. But on the right side, it stops right here with open circle because at 3 is not, this function is not defined. So this graph right here, stop it here with open circle because it's strictly less than 3. Now for the other portion, the square root of x, when x is greater than or equal to 5, it starts from here. So square root of x function looks something like this. But again, it only works when x is greater than or equal to 5. So start from here and greater. So that means this portion has to be erased. So you can think of it erasing, or you can just draw starting at 5. At 5, square root of 5 is about 2 points of number. So somewhere here. And we know at 9, let's say 9 is somewhere here, it is 3. Square 9 is 3. So here we have a curve. Start from here and goes like this. So this is not a straight line, although it looks like it, but it is a curve. So let me draw maybe a little better, like here. It is a curve. Right. Again, the square root function itself has this start from here, but because this domain is only when x is greater than or equal to 5, we only draw this portion. Let me erase these. So let me highlight the graph. This piece and this is part of this one function. Although there are two separate parts, this 2 is part of this one graph of one function. So then what is range of this function? Range. If you look at this, range is the y value. So y value start from 0. Range is including 0. And it goes up forever here. Right? If you look at up here, the function goes up forever on the left side. So it covers all the positive y value. So range is 0 to infinity. Again, let me note that this means these are y value. Or we can say the function value, f of x value. This also. So just because we write in interval notation doesn't mean they mean the same thing as here. Domain implies x values. Range implies y values. Write a formula for the function obtained when the graph of f of x equals x cubed plus 2 is shift up 1 unit and left to 2 units. So this is a transformation of a function. So we have x cubed plus 2. We want to go left 2 units. So that means first we have to go left 2, which means we have to add 2, then cube. So input, we must change the input. We have to go right, we have to go left 2 by adding 2, and then we input this to the function. Okay. And up 1, use different color. Up 1 means from here we go up 1. So we add 1 here, so plus 3. So this is a function that went left 2 units and up 1 unit from this function. So it's important to compare. It's important to think about which is the original function we're transforming to from right here. Graph square root of x plus 3 using transformation. Then list all the transformation. So in this case, when we say use transformation, is first draw the original Tokay function. In this case, square root of x. And square root of x looks like this. Here 0, 0. When it's 1, square root is 1. When it's 2, yeah, it's 1 point, some decimal number. So 1, 2, 3. We know at 4, we know it's 2. So with this point, and at 9, somewhere here, we have 3, right? So yes, this portion of graph right here. Well, let me draw a better curve, something like this. And it goes like this forever. The important thing about square function is that the Tokay function, it starts at 0. Domain is 0 to infinity. You cannot have negative number inside of square root unless we do some transformation. So from here, we're going to add 3. So this means we go up 3. So for each graph, we go up 3. So for each point, we go up 3, starts here. At 1, go up 3, right here. At 4, we go up 3. 1, 2, 3, 4. Oops, sorry. 1, 2, 3. Oops, let me draw a little better. So at 2, 1, 2, 3, like this. So your graph will look something like this. So transformation is up 3, or we can write vertical 3. And the final graph is this one right here. So make sure to don't get confused. This is different from square root of x plus 3, because in this case we have horizontal transformation. Right? So don't get confused. These are different. This is take the square root first and add 3, where this is add 3 first and then take the square root. Grab 3x squared plus 2 using transformation. So the Tokay function is x squared, which has parabola when it's 0, 0, 1, negative 1. 2 gives us 4. Negative 2 also gives us 4. Negative, well, positive 4. So this is the Tokay function, the parabola, which is x squared. Now from here, we have to multiply 3 and then add 2. So what does multiplying 3 do? Multiplying 3 stretches vertically. So let's list all the transformation. Vertical stretch. And also up to vertical shift of up to. So how this look? So vertical stretch means think as, graphing this here and here and vertically stretch this way. So it will make narrower. How much narrower? By 3 units. But what does that mean by stretch by 3 units? So we don't actually say 3 units, but what's important is we know that it becomes narrower. And the one way we can tell that is by just look at 3x squared. If you plug 0, we get 0. If you plug 1 in, now 1 does not give us 1, it gives us 3. Negative 1 gives us also positive 3. So as you can see, if you connect all the dots, it becomes narrower. So you can always test by plugging some points. And then from here, we go up by 2, up 2. So the final graph, let me draw in this black color. So this is the final graph. And I also highlight it so you can exactly see. So it's narrow and up 3. So this is the final graph. So we apply the transformation of vertical stretch and vertical shift of up 2. Graph negative parenthesis x minus 3 squared minus 6 using transformation. So again, this is the parent function or token function is x squared, which again the parabola of something like this. Okay, 1, 1, 2, positive 4, negative 2, positive 4, 2, positive 4. Right? Now let's list all the transformation first. Okay, so let's look at inside first. Minus 3, that means right to 3 units. And negative x, sorry, negative here means reflection. Reflect over x-axis. And negative 6 means down 6. So these are all the transformation. So from here, let's go to right to 3. So the same graph will be right here. We want to right to 3, like this. Now from here, I'm going to reflect. So let's reflect. So reflect on x-axis. So it will look something like this. Think as a flipping reflection. Okay. So reflection is good to think as rotating 180 degree along the x-axis. In this case, because reflect over x-axis. And then it went up 6 units. So this is 0. So at 6, here's 6. We have the same shape of the graph. Something like this. So this is the final graph. So let me highlight it. This is the final graph. Again, it's important to draw an arrow here because these graphs go forever. And when we do transformation, the order is always to the inside first, and what's multiplied, and then addition subtraction in the end. Which addition subtraction in the end is the vertical asymptote. Sorry, not vertical asymptote, vertical shift. Graph 1 over x minus 6 using transformation. So the parent function, or Touquet function, we call it, is 1 over x. And that function looks something like this. So let me draw it better. Like this. And this. Again, the both lines are part of this one function. So you have to shift entire graph down 3. So here, the transformation is down 3. So we shift this entire graph down 3. So we have, here is 0. This is 0 when x equals 0. So think as we're bringing this entire down, this line to x equals negative 3. And the y-axis stays the same. So then we have the same shape graph like here. And bring this one down here. So let me highlight this. So this right here and this line here, both of these are part of this one function graph. Is the function negative 3x squared plus 4 even, odd, or neither? Show algebraic steps. So if it were to be even function, f of x equals f of negative x. So let's check this first. So we already know f of x, so that means we plug f of negative x and simplify. We'll get negative 3x, negative 3 negative x squared plus 4, which simplifies to negative x times negative x is positive x squared plus 4, which this is same as, this equal to f of x. Therefore, it is even. Even. But let's also check if it's odd. In order to be an odd function, this has to be true. F of negative x must equal to negative f of x. But we already did f of negative x, right? F of negative x was negative 3x squared plus 4, which was actually f of x. So this is not, f of x is not negative f of x. So no, this is not odd. It's only even. Is this function x squared 2x cubed minus 4x, sorry, 2x cubed minus 4x, this is even, odd, or neither? So let's take even first. In order to be even, when I plug negative x, it should simplify to same as f of x, the original function. So if I plug, let me do this, negative x cubed minus 4 negative x, which is negative 2x cubed plus 4x, which is different from the original function, right? So not even function. But then let's check odd function. In order to be an odd function, f of negative x must be same thing as negative f of x. We already find f of negative x to be, right here, negative 2x cubed plus 4x. Then let's see, what is negative f of x? Multiply negative to this function. Negative 2x cubed minus 4, which we can simplify to negative 2x cubed plus 4. Now these are same now, right? We verify that f negative x and negative fx, when we simplify, they're same. Since they're same, then that means they're odd function. And neither function happens when it's neither even or odd, which we can only know by checking both even and odd. Is this function f of x equals 2x cubed minus 3x squared minus 4x plus, so even, odd, or neither? So let's check. So first, just plug negative x and see if that's equal to given original function. 2 negative x cubed minus 3 negative x squared minus x minus negative 4 times negative x plus 4, which simplifies to negative 2x cubed negative 3x squared plus 4x plus 4. This is different from this original function. At least we can tell by just looking at the first term. We have negative 2x cubed, but we do not have negative 2x cubed in the original function. So we know this is for sure not even function, not an even function. But then how about odd? For odd, we found f of negative x. We need to find now negative f of x. That means we multiply negative to this function. So we multiply negative to this entire function. Essentially distributing the negative sign here. We get negative 2x cubed plus 3x squared plus 4x minus 4. And if you look at here, this is different from f of negative x. They're different. I mean, this first term is same, but second term is different. Third term is same, but last term is also different. If one term is different, they are different. So it's also not odd. So this is neither. This function is neither odd or even.